I'm just giving you an introduction to the controller that I use on my Hornby Dublo model railway and explaining how this particular model meets my needs. First thing to notice is that it's made by a company called Gauge Master, who make a wide range of controllers of differing types. Now this controller here is a cased controller. What that means is that there's a big solid metal casing all around the electronics that are in there. It's a heavy unit, it's very robust. I mean, I wouldn't like to drop that on my foot. There's a fair bit of weight in that. The actual model identification is Q, which you can see there. There's 1, 2, 3, 4 dials on the control panel, and each of those provides a DC 12 volt supply out. So if you've got 4 circuits of track, you can run 4 trains all at the same time. So let's turn the controller on. It does make a faint humming noise, you may hear that, but it's not obtrusive, it's a bit of a background hum. Okay, so you'll have seen that each of these dials has an indicator light, and when I plugged it in, all these indicator lights came on. So that confirms to you that the controller is on and ready to work. Now if we look at the dials, we'll see below them is a switch. Each one has got a switch, and you use that switch to determine which way your loco is running. So you've wired up your loco and you've got it wired up in such a way that you want it to go forward, and you've got your switch in the forward position. Turn the dial and you'll see the light does actually change colour. It goes from the bright red, which is when it's first turned on, to a yellowy orange colour. So how do I make it go in reverse? Well, you've got a switch and you move the switch across. There's a middle setting on the switch, that's a neutral position, so it's basically off. So if you've got the switch in that position and you turn the dial, nothing's going to happen, the loco's not going to move. If you move it over to the R position, the reversing position, then you turn the dial, then your loco will move in reverse. Most of the time I prefer to run mine at a scale type of speed, and I find this setup here gives me the right sort of power and control to achieve some scale speed running. Well, here's the rear of the controller, and the first thing that you'll notice is that there's a warning label, safety risk, on the back. So I suppose I should have mentioned at the outset that if you are using any type of controller, particularly some of the older models, then unless you know that it's been properly tested and is safe to use, then you're better getting it tested out by someone who's qualified to make sure that you're not putting yourself or any of the people that use it at any sort of risk of an electrical injury. Now looking at the rear of this controller, you'll see here we've got the very clear labelling. We've got track 1, 12 volt DC and 16 volt AC, and we've got track 2. Now the track 1 and the track 2 are the controlled outputs. They're the ones that we use to power the locos on the track by turning the dial on the front of the controller. The other 2 outputs, I'll just come in closer on those, you can see here, they're for accessories. So if you're running signals, points, lighting, you can use the accessory terminals to power these items up with. In terms of connecting your wires, then these go in the rear of these terminal blocks. You undo the screws that you can see here, and you put the wire in, and then you tighten them up, and it makes a very secure connection. So you've got quite a solid linkage there between the controller and whatever it is you're powering. Over here on the other side of the controller, we've got tracks 3 and 4 linked up obviously to the control dials on the front of the controller, and again we've got another 2 accessory terminals there. We've got the 16 volt AC and the 12 volt DC. You'll see over here I've got a yellow and green wire coming out of the 16 volt AC uncontrolled accessory block. They're running to a handheld controller, and we'll look at that in a moment or two. As you can see, it fits nicely into the palm of the hand. and you've got the standard dial and the switch for forward and reverse at the base. You've also got the indicator light up here. See, at the base of the controller there is a white cable. The cable carries 4 separate wires. There's a yellow and a blue wire. Gauge Master recommend you connect this to a 16 volt AC supply. I've done that on the back of my Gauge Master controller. The other 2 wires that come out are these, red and black wire, and they simply get connected to your track. First of all, a brief explanation of how the feedback controller operates. What it does, it creates what's known as a closed loop between the controller and the locomotive, and the closed loop senses the load in the circuit and constantly adjusts the output from the controller. This means that the locomotive will have an even speed up and down gradients and around curves without you having to alter the regulator on the feedback controller. Gauge Master make it very clear that the feedback controller is unsuitable for portiscap or other coreless motors, or for poor quality mechanisms. What I've done, I've given both the locos the same sort of train to pull. So we've got a van, we've got a wagon, and we've got a guards van, and on the other one we've got a Sax Assault van, an open wagon, and a guards van. But the difference between the two is minimal. So we'll just see the inside loco pull away, and that's being powered by Gauge Master's Q controller. So that's creeping forward quite pleasantly. Okay, so that went well. And the outside loco, as you know, I'm using the feedback controller, so I'm setting the dial up to 10. I'm getting up to 20 on the dial. So at 20 on the dial, this one's actually creeping forward, and I have to say that the feedback controller is actually giving a far more steady, consistent, slow speed. This is really slow. Here on the layout, I've built a temporary gradient on a curve, so this is quite a good test for the feedback controller to maintain a steady speed all round here. So here's the loco on the outside track that's powered up to the feedback controller. So let's just watch it go around this curve in a moment. There you have it, slow and steady, round the curve, finding the gradient, perfectly steady, and coming down. I'll bring that to a stop. On the inside track, there's an equivalent locomotive, 4MT, with a similar load, 2 wagons and a brake van. Now I'm going to send the one on the inside track, which is just powered by the standard non-feedback controller, up the gradient. And it stopped, and I'm having to apply more power, more power, more power, more power. And the feedback one, which is just climbing over there, and I'm having to apply more power to the standard Gauge Master control to get it up the gradient. What I've decided to do is to do a test running of locos over a series of point work. So they're all going to run through these, and we'll see how they do. I'm going to set them all at the same sort of speed setting, which will be around about 20-21 on the Gauge Master feedback controller. Here we go. Cleared that first point, a little bit of a jitter, and it's cleared the other point. So I'm just going to bring that back, That's coming back very smoothly. Hopefully I've not spoke too soon. So there we go, just bring the dial up to 20 and the loco smoothly away over the first point, and the second and the third with no real problem. It seems slightly more powerful at pulling than the other two locos I've tried. It seemed to accelerate away a lot quicker. Bringing it back round, it's just up to 20. That's run very smoothly. It's great to watch the actual valve gear turning at these slow speeds. I think that was something that on this engine Dublo got absolutely spot on. Class 20 diesel ready to make a move on the test. I'm just turning this up to the 20 mark, and we're away. I think it's a bit noisier over there because there's nothing underneath the board, so it's a little bit of a sounding deck. But then maybe it is the feedback controller making the motors a tad noisier, but not by a huge amount. 20 mark and the castle's away. Yeah, as I expected, that's just running so smoothly through the point work. Just turn it off. Smooth, reliable castle. So you can see that is just creeping along. If I was you, I'd go make yourself a cup of tea and wait till it gets to the very first point, because it's going to take a little bit of time to get there. Here we've got the first point coming up. As you'll know if you've watched some of the other videos, you'll probably recognise this is a Hornby Dublo simplex point with dead frogs. So it's a bit of a challenge for any of these locos with the short wheelbases. But we've covered that one very, very well. So far so good. Yeah, continuity working well. We're now going into the other type of Dublo point, which is the one with the metal frogs. So it's got a live feed through the frogs. There's no shouldn't be any braking continuity here. I just can't believe how well this tiny little tank engine is doing, just crawling through the lowest of speeds. I mean, I guess if you were keen on shunting engines, then something like this at very low speeds would be just what you needed. And again, we're into the dead frog point, the simplex point here, and it's making progress. And that's probably so far, in terms of slow speed, that's the best loco. And I would say, because I've run DCC controllers, that's pretty much as slow as you can get. Well, that's pretty impressive. It's cleared that point at a very slow speed. I like it a lot. Let's see how we go. There she goes.